So from here on, we'll try to understand the major, like the problems, or we'll try to decode the problems based on the loans and their repayments. Now, there has been lots of problems in IB that has been asked on the loans and repayment. And before I go to any problem, I would like to explain you the structure or the general idea about how the loan repayment happen. Now, for example, I took an interest. I took an interest of. I mean, I took an amount of, let's say, 10 lakh rupees as a loan. The bank is going to say that, okay, you have taken the loan, so you got to pay certain EMI. That's like how much, like, month at every some fixed date of the month. I have to pay a fixed amount of the, what do you say, repayment, or you say every monthly, like, in smaller installments, I make the payment. So I decide that, okay, for whether my loan is for 20 years or 10 years or 30 odd years, I decide on that fact. And okay, based on that, there is the EMI that is calculated. So what is really interesting is that how does the outstanding amount. So today I have borrowed, let's say, 10 lakhs, and I pay an amount of 1 lakh of, let's say, repayment every year or every month. Let's say I'm paying 12,000 or something. So how much is my outstanding amount? Let's say today I paid 12,000. From there, bank had given me some amount, so they will calculate interest on that, and then my paid amount becomes minus from the net amount that I owe the bank. So there is a word that is called an outstanding amount. So when you talk about outstanding amount, so let us say today I went to the bank, I took the money P, amount P, bank will charge its interest, and then I pay at the end of the first month, I pay some EMI, and then they minus it. And for them, this becomes the principal amount for the next month. So let me just kind of read a problem. Probably that will help us to understand this topic better. How does the loan repayment happen? So I'm going to take one of the IB specimen problem. That is, I'll take, let's say, this is one of the textbook questions from Fabio Cerrito. So let's say Linda borrows $2,000 at 1% of monthly reducible interest. If she repays the loan in equal monthly installment over 4 years, how much is each installment worth? Like how much total money she paid also can be calculated against this 2,000 that she borrowed. So now the first thing here is like, here understanding the logic is important. If it's like, let's say the bank is paying, I mean, she borrows at 1% of interest. So what does the word reducible mean? So if I pay an amount, let's say I pay a certain amount as a EMI, so the bank is going to calculate the interest on the outstanding amount. They're not going to calculate on the principal amount every year. So consider that, like how this entire process happened. So now let us say I am talking about AN is the outstanding amount, outstanding amount, outstanding amount after eighth repayment. Like A1 means I just made my first repayment, means at the end of first month. So if this 2,000 is in the bank, I borrowed for my usage, bank is going to charge the 1 month of interest on this 2,000. So this 2,000 that I have taken, bank is going to charge certain interest, but luckily I paid this amount to the bank at the end of first month. So what I'm going to do is I'm going to show it to you. How does this thing happen? So bank is going to charge interest on this 2,000 for 1 month. So this 1 month will be 1 upon 100 to the power 1. So this will be the payable amount at the moment I'm going to make my first repayment. It'll be like 2,000 into 1.01. So this is what I owe the bank just before my first EMI. I am lucky enough to have a salary in my account, so I pay that money to the bank. Let's say I pay an M amount every month. So now this is going to be the outstanding amount after first repayment, after first monthly repayment, this is going to be outstanding amount. After this now comes another story, is now bank is going to think, okay, what do we do next? Is they are now going to calculate. So this is going to be my A1. Now suppose I'm just about to make my second monthly installment or monthly repayment. So now what will happen is that for them, my A1 becomes the principal amount for the next month. So this money I owe still to the bank, and they will charge an interest of 1 month on that, raised to 1. And then again, I am lucky enough to have still a job and then pay that amount M to the bank. So A1 becomes principal amount for second month. So logically, kids, here the most fascinating fact is now this could have been my expression on which I will calculate the interest for a month minus M. If I do, I get this. Or I can do is I can substitute the value of A1 that I've got here. So I'm going to put that value here. So it'll be 2000, 1.01. Don't simplify this so that you can figure out the trend, what's happening. So that value I put here into 1.01 to the power of 1 minus M. So now what you do is you observe this, what's happening. So A2 is going to be, now if you open this, you're going to get 2000 into 1.01 square minus M times 1.01 minus M. If you open up, so 1.01 times 1.01 is 1.01 square. M times 1.01 is this, and minus M. So this is the amount in the, what you can say is that due after my second repayment. Now, if I want to calculate what will be my outstanding amount after my third repayment. So A2 will become my principal amount, and it will be with me on the bank for, let's say, a month. I mean, bank is going to charge, and then I am lucky enough to pay M at the end of third month. So this money, if I basically multiply this by 1.01 and then minus M, I'm going to get A3. And if you see that, it is going to be simply 2000 into 1.01 to the power 3 minus M. Now, if you multiply this with this, it will be M times 1.01 square minus M times 1.01 minus M. So this will be the outstanding amount after third repayment. So now, since you can see that this is actually forming a pattern, and the pattern that you notice is here, it is clearly shown. I would like to take this now from here on. So you can see that this pattern is that this power that you notice is growing as this. So outstanding amount after third month, this is 2000 into 1.01 raised to 3. If you take minus M common, that this forms a geometric series once again. Outstanding amount after fourth month will be, I can create the pattern, will be 2000 times 1.01 to the power 4 minus M 1, 1.01, 1.01 square, and 1.01 cube. And so after n months, after n repayments, this will be the outstanding amount. This will be the outstanding amount. So you can see that happening here clearly, that so let's say after n months, like if you see here, it is the power n and starts with like 1, 1.01 and so on, and this highest power is 1, always less than the repayment that you made. So that's why this is 1 to the power n minus 1. So now, since they're saying that this entire amount gets paid after what you say is 48 months, since 4 years they had mentioned in the problem. So they had mentioned the problems of 4 years, like 48 months. So n here is 48. So if you find the sum of these terms, and obviously there's no outstanding amount because I have completed my loan at the end of 4 years. So this is going to be 0. And if you solve for m, this forms a geometric series. You can find the sum using the geometric series formula. And so yeah, so this is the geometric series formula. You can see this, they have found the sum here, which is u1 upon 1 minus r raised to n upon 1 minus r. That comes to be 61 point this. I took this thing all out here. This thing has been taken all out here, and this remains here. So if you divide this entire thing down here, Obviously, we calculated using this formula. So your answer will be 52.67. So in short, I paid the bank 60 to $52.67 every month as the prepayment or as the repayment of that loan, or you can say as a monthly installment. So this is the general logic of housing, or like, loan repayments, or any kind of loan that you take where you decide to pay through an EMI. This is more or less, this is the same logic that works. So I'll just kind of summarize now. So if 52.67 is the amount in total, she actually paid 52.67 times 48. So this much is the amount that she paid against the money that she had borrowed, which is 2000, which was 2000. So you can calculate this and you can find out how much did she pay total in order to complete that loan process.